Hi guys, today we are going to solve a problem called verifying an alien dictionary. It's the Facebook's most asked question. And the description is in an alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if given orders are sorted lexicographically in this alien language. One of the examples that they've given is that there would be a string vector words where they have example of uh, hello and lead code. Now, when we'll be seeing in the order list, so they have a certain kind of order here. The alien language that has an alphabetical order, for example, just like English letters have an alphabetical order called A, B, C, D. So here they have given an order of the letters. When we see that H is the first letter, and here the L is the first letter. Now, when we see the order, H comes before L. So this is sorted in lexicographical order. So the output would be true here. An example two, when we try to see that when they've given an example where the first letter is word, the second letter is word. So when we compare both of these words, so the first letter W is this same here, W, O, O, R, R. Now here we have D and here we have L. So when we try to see in the order list, uh, so since the starting three letters are same and D comes after L. So here the problem is that in the second letter we have L and here we have D. So this is not sorted lexicographically. It should be the other way around, that word should come before word. Therefore, we'll return false. And in the third example, when we try to see that apple and app is given, and now when we compare both of these words, so first letter is A, here the first letter is A, then P, then P, then P, then P, and then in the second string, the letters, there are no more letters. So uh, explanation that they've given is that the first three characters app match and the second string is shorter in size. According to the lexicographical rules, apple should come before app. Okay, so because L is greater than null, where null is defined as the blank character which is less than any other character. So what they mean here is that basically if there's a shorter word, and basically if there's a shorter word and we are comparing to the other word, then the shorter word should come before the bigger word. So that's why they've returned false here. The constraint that they've given is that word length should be between 1 and 100. Sorry, words length should be between 1 and 100. Words of I dot length should be between 1 and 20. Order dot length is given as 26. Okay, so there are 26 alphabets. All character in words I and order are English lowercase letters. So everything would be in lowercase. So what we'll do here is I'll just try to explain the code. Then it would be more easier for you to understand the question. So what we'll do is that we'll create a loop with I is equal to 0, words dot size I plus plus. Now we'll so since we are going to compare both first, we're going to compare two uh, letters, two strings, sorry. So uh, we're gonna make two strings. So for example, we'll create string word one is equal to word, okay, word of I. words of I, and string word 2 is equal to words of I plus 1. Okay, so since we're going from I to I plus 1, so this is would be word start size minus 1. Um, Now, since we have two strings now we'll be comparing both of these strings. So for that, we'll create two pointers, I1 equal to 0, I2 equal to 0. And we'll create a for loop for comparing these words. So till the time word if I1 is sorry, word 1 of I1 is equal to word 2 of I2. Till that time we will be increasing the pointer by 1. That is, we'll be shifting the indexes. So for example, if I1 is here, I2 is here, so then we'll be shifting it till the point we get equal letters. And now when this condition becomes false, they will get out of the loop. And at that time, what we'll do is that we'll be finding where these words, the word of I1 lie in the order list. So for that, we'll be creating a integer r is equal to um, order dot find word 1 of I1, and integer left would be equal to order dot find word 2 I2. Now this will give us the indexes of the letter which is not equal in both of the strings. And uh, just like in the explanation that we were trying to find if the letter of the first string is before the letter of the second string. So that's what we'll be doing here. So if r is greater than s, then we'll return false, and otherwise we'll be returning true. So let's run this code. Um, okay, then, sorry. Yes. Nice. So here, let's talk about the time complexity. Um, since we are going through each string once, and uh, we will be checking it otherwise in if the two strings are equal. So the time complexity would be O of the characters that would be there in the string, and the space. So everything, we haven't used any space here. So the space would be O of 1, and because the variables are constant, we haven't used any space here, so it would be O of 1. All right, so this was a question that was most asked in Facebook. I hope you get it. I hope you understand. Thank you.